Hello, everyone. Welcome back to another episode in Adventures in Machine Learning. My name is Michael Berk. I'm going to be the only host today. Ben is out with some personal things. Everything is all good, but unfortunately, he will not be with us today. Today, we have a very special guest, Edouard, and we are going to be chatting through some potentially very technical topics, but learning about his organization and what they are doing.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So do you mind introducing yourself, explaining why you're famous?
Thanks for having me, Mike. First, I'm very happy to be here with you today. So I may be famous for several things. First one is I'm the CTO and co-founder of Kili Technology. We are a data-centric AI platform. What we see today is that in AI we have quality issues, and on one side, and on the other side, that trustworthy AI is priceless. And those issues, for instance, 2016, you remember Tay, the bot from Microsoft on Twitter that became racist right after its launch. They estimate the pricing algorithm from Zillow last December. They experienced a loss of $500 million. And so the thing is that maybe those last few years, the focus was a bit too much on the algorithm in the AI community, and not that much on the data. Tay was fed with both positive and interactive and negative interactions without any human filtering. The estimate was made of more than 1,000 submodels. So we should probably be a bit more data-centric, and this is what we are trying to push. And before that, I was leading the AI lab of BNP Paribas. And before that, I started my career at Lehman Brothers, right before the bankruptcy.
Wow, what was that like?
Yeah, in fact, I was the very latest employee of Lehman Brothers. Like, I was their latest hire, and so it was super weird to see the bankruptcy of such a giant, a leading company in their sector. And so you realize that even giants can go to bankruptcy, and this is something that has some echo today, because for instance, Elon Musk says, if you're not worried about AI safety, you should be, because it's vastly more risky than North Korea. And I think that we should change a bit the way we develop AI to be more cautious, because it can have big consequences, both in terms of delivery, but also brands, but also maybe at some point bankruptcy.
How do you define cautious AI?
Like, I think it's AI that we can trustworthy AI. So AI we can rely on. And I think the way to go in this direction is to realize that what matters when you develop an AI is not anymore the code, but the data. The data is the new code for AI. And particularly, data quality matters. My day-to-day experience is that what makes or breaks an AI project is not the algorithm, but the data and its quality. And this data quality means two things. It means having clean data and having diverse enough data. And this is something that I think the community is just starting to explore. Like, we are just about to build the tools to understand if data sets that we are using to train AI are consistent or not, if they are well balanced or not, if the different edge cases, scenarios that our model may face in production are present, included in the data sets, and with enough courage or not. So
Yeah,
this is a new world to explore.
Yeah, I could not agree more. I've found that with a linear model, we talk about this a lot on the podcast, that a very simple model and great data can solve a use case. If your data relationship from between X and Y is fundamentally linear, you can throw the biggest, baddest neural net at it. A linear model will outperform it, be easier to maintain, easier to troubleshoot, and a lot cheaper to serve. So completely on board there. But I was curious about some of the tools that you mentioned about defining clean data and diverse data. How do you know that data are clean or data are diverse?
So consistency. So having clean data matters because AI is garbage in, garbage out. So if you have inconsistent data, it's going to confuse your model and to decrease the performances. And so, for instance, I have three figures in mind. What we see on our project, on the projects that we manage for our clients, is that a 10% decrease in the label accuracy means a 2 to 5% decrease in the model accuracy. And it also means having to double the dataset size to keep the same performances. And by label accuracy, I mean, if I ask several labelers to label the same data, they won't probably have the exact same answer. Like, for instance, if I ask them to label, cars on images, if I'm not specific enough in my instructions, one of the labelers will put a big bounding box around all the cars, and the second one, a small bounding boxes. And third one, maybe also small bounding boxes. That's probably better, because more precise for the model, accurate. But this kind of inconsistency will have an impact on the model. And so an impact from 2 to 5%. What we see in our projects is that on average, the consensus between labelers is about 85%. So it means that they disagree on 15% of the assets, of the images of the documents, which is big, which is huge. And it has an impact on the performance of the model. I said from probably 2 to 5% in terms of model accuracy.
And out of curiosity, what kind of projects are these? Are these image classification? All of them, or?
Yeah. So at Kili, we are pretty universal. Like, our solution covers text labeling, so text, PDFs, structured text, so everything related to document processing, images as well, videos, audio, time series. So it's pretty universal.
Wow. So this 80% or 85% comes from all of those different subjects. It's not just one.
Yes.
Got it.
No. Yeah.
Interesting.
And the second challenge is so having diverse enough data. So how do you manage so why that? Because a model cannot invent anything. Like, it can only be as good as the data it has seen before. And so you need to make sure that you have enough examples, that enough edge cases. And in parallel, I think that 40% of the data in data sets is like a duplicate, so redundant, so having no value. So if you manage to smartly, properly select the data you label and you include in your data sets, you both improve the performance of your model, so the robustness of your model, and also you decrease the data preparation effort, the labeling effort, removing this duplicate data. And so to do this, a bunch of methods. So to both manage the cleanliness of the data and its diversity. So from metrics to workflows to tools, bunch of methods. And our job at Kili is to embed this into a tool that forces those best practices in customer projects.
That sounds like a holy grail solution. You can know that your data are good enough. Is that basically what happens?
Yes. So our vision is that, data is the new code for AI. Like, and AI is software 2.0. Like, software 1.0, traditional software, Python, for instance, is about writing some lines of code. Software 2.0 is AI, And it's having a neural network figuring itself what are the relevant rules to get the desired output. And when you code in Python, you use an IDE, like a development environment, such as VS Code, a Jupyter Notebook, something like this. What we are building at Kili is the IDE for software 2.0, so for AI. Coding AI, coding in this software 2.0 stack is about accumulating data, labeling this data, messaging this data to select the right one. And so what we build is a tool where you can accumulate this data, label this data, iterate, facilitate short iterations, because it's all about iterations. So bringing agile, and maybe we can talk about it later in the AI development. And also, for instance, having some linting, the equivalent of a linter. So checking the labeling, the equivalent of auto-completion. So like, suggesting, the right labels. So this is basically what we are doing.
Got it. And so you have an interesting background. I wonder how that background turned into Kili. Was there some project where you were like, oh man, this sucks. I wish I had better data. So was it out of a need for yourself, or was it out of need from a stakeholder or a boss? What is the founding story of Kili?
Yeah. So I was the first user of Kili. Right before Kili, I was the head of AI at BNP Paribas. BNP Paribas is a European bank. It's the leading European bank. It's the biggest European bank. And in 2015, they realized that they had massive amounts of unstructured data that they were not leveraging. Other banks are pretty good in terms of structured data. So everything that fits in an Excel file, or all the time series, order book data coming from the trading and the financial market side. But you have massive amount of unstructured data, for instance, in emails, contracts, feed of news, scans of documents, chatbots, for instance, Bloomberg chats, in phone conversation records for traders, for instance. So a lot of unstructured data, and we could not process this data. Like we were stuck. The API, the machine learning APIs on the cloud were too generalist. Like, because in finance you have a lot of super specific vocabulary, financial vocabulary, and so we had to train our own models. We had this raw data, but the data was not labeled. So we needed to have a labeling tools, like a labeling platform. And on the other side, a lot of people in the organization had a job that was very similar to the job of a labeler. For instance, if you work in compliance and your job is about contract screening, so meaning reviewing all the people names in the contract and making sure that they are not in a sanction list or blacklisted. Your job is to do a name entity recognition. So you read the contract, you extract the people names, and then you enter them into the system. And so what we did is we created a platform, and that we put in their hands, in the hands of those subject matter experts, and then we collected their feedback, and we use it to start training models and to help them be more efficient, so suggesting pre-labeling, and also to do less mistakes. So creating this first data labeling platform internally at BNP Paribas unlocked for us a lot of topics, a lot of subjects, and the team grew from 2 people to 50 in a few months. And after a few years, I decided to resign, so to leave the bank, to start my own company. And discussing with other people, we rediscovered this data labeling need, which is like the very basic, like the basis of the Maslow pyramid when you do machine learning. And so we developed Kili. So the first added value was those interfaces. So just having interfaces where you can see the image, put the bounding box. So very simple. Second level was about collaboration. So creating collaboration, allowing collaboration between the different labelers. And now it's about, as we were saying, creating this data-centric AI loop where you manage to create collaboration between the subject matter expert labeling the data and the model being trained on this data and helping the subject matter expert to create as fast as possible data sets and data sets as reliable as possible. So making sure that there are no inconsistencies in the data set.
Got it. Can you explain that in a bit more technical depth, how the labeler and the model work together?
Sure. So labeling is all about collaboration. So this is the very first thing. Like you need, but just to give maybe a bit of history perspective, a huge revolution in the software industry 20 years ago was agile. It was the idea of Martin Fowler, and he said basically his starting point was that you should to improve the velocity of software development and the quality of the software, you should make the development of features and their testing concurrent activities, forcing more interactions between the software developer, the software tester, the project manager, and the user. And what we do in AI is exactly the same. So we make data labeling, model training, model testing, concurrent activities, so that there are more interactions between the labelers, the machine learning engineer, the subject matter experts, the project manager, and the machine learning user. And so the way it works is super simple. So Kili is designed to have on one side the labelers, so labeling on the images or on the documents, so on the user interface. And on the other side, you have this API where the machine learning engineers can plug models, collect the already labeled data, train the model, and push pre-labeling for the labelers. So having this human in the loop process to accelerate the labeling. And of course, you cannot use a model day one, the labeling project, at least if you don't have a previous version of a model. And so usually the way it works is, so you have several phases. So you work with small batches of data. At the very beginning, so you set up your project, and usually it's done by the machine learning engineer, because the machine learning engineer is the one that understands the way the model will work, the way the data should be labeled. So this person, the machine learning engineer, set up the project. So like the ontology, so the categories or the entities that you want to recognize in the text, etc. And he labels himself like 50 to 100 data to check himself. First of all, if the ontology, like the labeling plan, is well defined, if the instructions are complete or not, like edge cases, are they properly explained, and so on and so forth, and to get an idea of what is in the data. And then, so after this first batch, if everything is okay, you can start onboarding labelers and to make sure that there is no decrease of quality during this onboarding, he will use quality metrics. So for instance, the consensus, which is an inter-agreement metric, to make sure that all the labelers agree together, or the honeypot, which is, for instance, another metric that compares a ground truth, so created by the machine learning engineer, for instance, and the labelers. And the labelers will start labeling like same thing, 50, 100 data. If everything is okay, then we can go to the next step. If there are some mistakes, then the machine learning engineer needs to maybe update the instructions, train a bit more the labelers. But if everything is okay, you can go to the next step, increase the batch size, maybe have a bit more labelers, maybe onboard also a reviewer, maybe onboard some external workforce, etc. But the idea is really to do it in an interactive way. A batch lasting not more than like between 1 and 2 days. Otherwise, if you create this tunnel effect, what happens, and I saw it on some projects, is that you get your data set fully labeled. There are some mistakes, like the ontology of the labeling was not properly defined, but it's too late. The labelers, if there are internal people, maybe they also have another job, and so they went on something else, and so you are trapped. So the idea is really to size things, and you can embed a model at the very beginning of the project and at the very end of the project. And those models are not the same. At the very beginning of the project, you use like a rule-based model. So you collect as much business knowledge as you can. So for instance, if you want to recognize people names in emails, you may have a dictionary of first names, for instance. If you want to recognize, or you can have some regular expressions, or you can have, I don't know, something else, like labeling functions, and you use them to massively pre-label data. But with this, you will label maybe between, let's say roughly 20% of your data sets, like the very easy cases, not the edge cases that will actually bring a value to them. So then you have to go manual, by hand. This is the painful part, but you cannot escape it. And this is the one that brings value. And at the end of the project, when you label like 80% of the data, you can use the labeled data, so the already labeled data, to train first machine learning model and use it to pre-label the last 20%. But only at the very end. Otherwise, if you do it too early in the process, you will create a bias for your labelers. So this is a bit the way it works.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. You know, whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
Got it. So to sort of recap, we start off with a decision tree-esque label structure that is autocomplete for people who are going to be labeling or suggested results. And then iteratively, we increase the complexity of the model as the labelers label more data. Is that more or less the one-liner?
Yes. So so I think if we need to if you want to just keep in mind two things, the first thing is you need to do it iteratively. So and have small iterations when you label. And the second thing is you cannot. So there is no magic. There is no getting rich effect in a labeling project. You cannot use a model from the very beginning to ease completely the work of the labelers. But what you can do and what works is rule based at the very beginning, then by hand, and at the very end of the project, training a model and using it to produce more data massively, and so to refine the performance of your end-to-end model.
Right. Okay. What happens when there is let's say there's an image, it's very blurred out, we're not exactly sure what's on there. Do we allow labelers to say, I don't know, or do they always have to pick a class?
So you are allowed to say, I don't know. You can skip an image. And in fact, I don't know, or when two labelers disagree, this is a signal. And this is a signal that you should take into account. And so with this signal, you can do several things. Maybe the way you want to label your data is not properly defined. So for instance, maybe the categories you want to use for the classification job are not separable. And this can happen. Like the job, the labeling task was not properly defined. And you find it with this kind of, in this kind of situations. And if two humans cannot separate two classes, it's probably going to be non-feasible by a model. And it can also give you some insights, the way you selected the data, and help you to refine the sources of the data sources that you use.
Yeah, that's super interesting. I remember a few episodes ago, we chatted about sort of probabilistic modeling with using conformal inference for prediction intervals. And basically you have sort of a confusion matrix of the probability of being in one class, both classes, for a binary label, one class, both classes, the other class, or neither class. And that allows a lot more accuracy because it allows the model to not have to make a bad guess. So if it's right on the 50-50 threshold, it can say, I don't feel comfortable. We're just going to not classify this. So that makes a lot of sense. I was also wondering if we could circle back to something you mentioned at the very beginning, which was defining trustworthy AI, because I think these topics are very connected. Often models, when they're put in a pinch and forced to classify something that they shouldn't feel comfortable classifying, it can lead to very unpredictable results. So can you elaborate on what you meant by trustworthy AI and what Kili's doing in that realm?
So the way we address this, so the need of trust in our AI is through data. So what we think is that to create trustworthy AI, we need first thing is to create a common understanding between the machine learning engineer and the subject matter experts. When you tackle a machine learning, when you address a machine learning use case, there are two kinds of expertise that are important. The ones of the subject matter experts, like for instance, if I want to detect cells for the bladder cancer, or if I want to process some kind of super sophisticated contract documents, legal documents, the expertise of the subject matter experts is super important. And the machine learning engineer need to understand and to learn and to have in mind when building his model some piece of information from this model. And same thing when those people level, they need to have in mind the way the model may use the information or not. Is the context rich enough to make the extraction of this piece of information from the text document possible or not? And so the first thing to manage when you want to create trustworthy AI is to make possible this common understanding of what the model will do, and so the way to do it is one way to do it, to move in this direction is to be able, for both of them, so the machine learning engineer and the subject matter expert, to visualize the output of the model, the way the model made this decision. And so this is something that we do at Kili. So, and that is super simple, but super powerful. Like you are able to, so both the engineer and the subject matter expert to see what the model does, why it does it, and so on. So this is super important. And then with that, and the second thing is controlling the data the model is trained on. So like having an understanding of what is in the data set, what are the edge cases that have been covered, that we covered when building the data set, maybe the edge cases that we voluntarily excluded from the data set. And so having this in mind, you are comfortable and you have a well-defined range of application for your model. And this is super important. And so the way to do it is to build your model, is to build your data set in an iterative way where you start labeling some data, you train a model, you test the model on the data, you identify the failure modes, and then you source more data to better cover it. This can be named data boosting, so data boosting, which is you have a bunch of data that you can you can label some data. You could also augment this data to have a lot of data, and then you tactically or strategically include slice by slice some piece of this data in your data set. So from the data reservoir to your final data set to make sure that you have enough examples to cover the edge cases that you are interested on.
Okay, got it. And what type of algorithms / visualizations do you use to show what parts of the data the model is using?
So, for instance, one thing that you can do is visualizing when you do either text, so document classification or name recognition, you can visualize with saliency map the contribution of the tokens in the context of for instance, the entity you extract. and you can see the positive and the negative contributions to the decision of extracting, so far of identifying this entity, and use this information to source more examples containing the same context. So visualizing, opening you open the document, you have the entities that your model extracted, identified. You visualize the context of the entity, like the words before and after the entity, with their contribution. Is it positive? Was it negative for the model? And then if the decision of the model was wrong, was bad, then you can see what were the biggest contributors to this bad decision and choose to source more examples containing the very same context, because probably then your model will do the same mistake again because the context is similar. And so you will properly label those documents and include them in your training set to force your model making the right decision seeing this context.
That makes a lot of sense. So if there's problematic areas of the data, let's say, along a given feature, we'll throw more contexts where that feature is present to hopefully correct future labels.
Correct. Yeah.
Specifically from like an algorithm perspective, how do you define what areas of a feature are problematic? You mentioned like looking at positive and negative, almost like impact, but what algorithm specifically, if you're allowed to share?
You can use the usual suspects, such as Lime, for instance, or those kind of models. And so there are a bunch of tools like this. And I think the challenge today is less on the algorithmic part, but more on having the tooling to navigate this data. So, and for instance, I remember like a few years ago when I was doing a lot of ML projects, I was collecting the data, but I had no tool to get a global overview of what was in the dataset. Some packages were existing on Python, on GitHub in Python, but I had no tool, no search engine to filter the data, pre-visualize it, and so on. And I think the challenge that we have today is to create those kind of platforms. So where we can plug those packages, such as Lime, for instance, there are many others, and to visualize this data and to leverage it, searching, slicing the data.
Got it. Okay, cool. Yeah, I'm a big fan of Shapley values as well, and they're almost similar or almost identical concepts. But yeah, cool. One other question that I had regarding this issue is data sets are big. How do you scale this system, especially when you're often limited by human constraints? How do you handle iterating? Have you found a sampling trick that allows you to work with really large data sets, or what is your attitude towards scaling this method?
So I think scale was and has been so far super important. Like when labeling for computer vision, it was about labeling from 10,000 to maybe 1 million images. So huge scales. I think it's becoming less and less true thanks to foundation models, transformer models, for instance, self-supervised models that had a huge impact in NLP. And those models require less and less data. Because they are pre-trained, you can use just a few thousand examples and get super good results. And I think this is a super good news because the data is code for AI. When you double the number of lines of code in a project, you need to double the number of tests, unit tests that you create to cover the features and to manage this complexity. So when you double the dataset size, you theoretically double the number of tests you should apply on your model. And so you double, in fact, your technical depth. I think data depth is something that is super underestimated today. And so having those pre-trained models is a very good news because it decreases the labeling effort, but also it allows to decrease the technical depth related to data volume. The other thing is that, okay, you can use less examples, but you need to have very high quality examples because one example will have more impact. And so any mistake, any error, any labeling error will have potentially huge impact on the performance of your model. And so this is the reason why we think that today we were a lot on labeling fast, creating big data sets we need to be more focused on creating small but high quality data sets. And of course, when you use a foundation model, this model has been trained on some data that may be of low quality. And so we need to develop the concept of data card, so having some lineage information, the model, the data set it has been trained on, stuff like this.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Got it. Yeah, that makes a lot of sense. And especially if we start off with poorly labeled data at the beginning of the iterations, that can have a much bigger impact than later on. So that makes a lot of sense.
Definitely, yes. Yeah.
Do you guys do like a once over at the very end to see if the overall accuracy of the training set is high in terms of the label accuracy?
Yes. So we allow our users to test the data basically. So to have this linting of data to check the quality of the labels, the consistency, and you can do it at several levels, like at the project level, so the dataset level, but also at the labeler level, at the asset level, at the image level. And you can use several tools to do it. It can be role-based, like checking if you label houses and windows. Okay, windows are supposed to be on the wall, not outside a house. So you can check those kind of things. So role-based. Very simple. At the end of the project, when you already have a model, you can compute the likelihood of labels. So based on the comparison between what the model predicts and how the ground truth was defined by the labelers. And based on this information, you can prioritize the review. So target the review. When you label, usually there are some labelers doing the work, and then you have a super annotator, super labeler, reviewer taking maybe 10% of reviewing 10% of the data, double checking. And the thing is to make it targeted. So reviewing the assets where it matters.
Got it. So that might be the ML engineer or the subject matter expert that would go in and do sort of a once over of problematic areas or potentially problematic areas.
Correct. Usually it's pyramidal. Like at the very bottom, you have like a model layer that can pre-label massively, and especially at the end of the project. Then you have the labelers, so using those pre-annotations to label. Then you have the reviewer doing less job. And at the very top of the pyramid, you have the machine learning engineer that can review job done by the reviewers.
Got it. That's super cool. And it also gives the ML engineer the most power, which is fun, at least for this podcast.
And it's also because it's the ones that has the highest salary. So
true. Yeah.
To space time.
Yeah. So a couple concluding questions. If people are not using Kili and they're in this sort of iterative labeling process, what is one piece of advice you could give to them to make the process more efficient or more accurate?
You mean the labeling process, right?
Yeah.
So I think the most important thing is to do it iteratively. Do not create a tunnel effect. Build your data set iteratively. So start labeling maybe randomly some images, some documents, and then use this information to update your labeling project. So to update your instructions, to update your ontology, so the way the categories, because they may be not properly defined, and to update like the labeling queue. So the data set, the assets, the images that you are willing to label, because maybe you want to better cover some edge cases. And so my strongest advice would be to iterate. So always iterate, proceed with small batches, 1-2 days at most.
Got it. So don't just improve on the model side, also improve on the labeler side by providing better instructions, potentially sampling different areas, that type of thing. Got it. Amazing. And then final question, if people want to reach out and connect with you, where can they find you?
So bit everywhere, on our website. So it's Kili Technology.com, on Twitter, E-Darchambault, it's my own ID, or Kili Technology. And we have offices both in the US and Europe. So
amazing.
We are kind of super available.
Cool. And that's KILI, but we'll also include links in the show notes.
Correct, yes.
Cool. Well, this was fun. I think this concludes our episode. Thank you so much for joining us. And for those listeners, stay tuned for the next one. Thanks, everyone.
Thanks, Mike.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.